Hi friends, in today's lesson we are going to consider how to solve given Surdic or radical equations. So if you are a student that find it difficult to solve given Surdic equation, or you are simply a math lover that wishes to expand your knowledge on the solution of Surdic equation, watch this video to the end. I guarantee that this is the video you've been waiting for. Now, Surdic equation or radical equation simply means those equations that contain surd or radicals. And if you encounter any given Surdic equations, these are the steps you need to take in order to solve them. First, you need to isolate a single radical surd on one side of the equation if that is possible. But if it is not possible, then this first step might be omitted. Now, after you must have isolated the single radical on one side of the equation, the next thing you need to do is then to raise both sides of the equation to the power in order to remove the radical. And after you must have done this, then simplify the result. Now, what this simply means is that if the radical involves square root, you raise both sides of the equation to the power of 2. If the radical involves cube root, then you raise it to power of 3. If it involves cubic, quartic, depending on the root, you also raise its power to correspond to the root in order to remove it. Now, sometimes you might apply the second step and you still find out that other radical still remains in the equation. If that happens, then you then need to repeat first step and also second step. But if after you must have raised both sides to the power that correspond to the root, and then the root is removed, you simply go further to solve the resulting equation. And when you must have solved the resulting equation, the next thing you need to do now is to check whether the solutions, what you have obtained, actually satisfies the given or required equation. Now let's illustrate these steps using this simple example. So here we are to solve the square root of 2x plus 1, then plus 1, all these sides to be equals to x. Our solution or our mission here is to obtain the value of x. And so if you should follow the first step, that is to isolate this radical, that means that I have to subtract 1 to both sides of the equation. And if I do that, I will have that the square root of 2x plus 1, then plus 1 equals to x. I will then have that I have to subtract 1 from both sides of the equation, and this will then imply that I will then have 2x plus 1 here. This will be the same thing as x minus 1. I have isolated this radical to be on one side of the equation. So the next step now is for me to raise both sides of this equation to the power that will remove the square root. And because this is a square root, I have to square it. And if I have cube root here, that means I have to take cube to both sides of the equation. So that is what the second step is here. So if I should do that now, I'll then have that this is square root of 2x plus 1. I will square it to be the same thing as x minus 1. I will also square it. And so when I do it now, this square will cancel this square root, and this will then imply that 2x plus 1 will be the same thing as, so I have to then expand this side, and that will exactly give us x squared minus 2x plus 1. So because this is like x minus 1 multiplied itself 2 times. So I have x times x here, which is x squared, then x times minus 1, which is minus x, and minus 1 times x, which is also minus x, and minus x will give us minus 2x, then minus 1 times minus 1 will give us plus 1. And if I do that now, this will then imply, I'm now trying to simplify this whole expression. I will then subtract x squared from both sides of the equation, and I will then have minus x squared here. I will also add 2x to both sides of the equation. I will then have plus 4x here, and I will then also subtract 1 from both sides of the equation, and then here we go, and this is equals to 0. And if we do that now, I can go further to factor x from this side of the equation, and this will then imply that x here will be minus x plus 4 equals to 0. So at this junction, I will apply AB equals to 0 principle, And if I do that, I'll then have that either this x here is equals to 0, or this one here minus x plus 4 is equals to 0. So this will then imply that either x is equals to 0, or if I should add x to both sides of the equation, I'll then have that 4 is equals to x, which will also imply that x is equals to 4. So we have obtained two possible values of s. One is that s is equals to 0, then the second is that s is equals to 4. Now, if we should check these solutions and then replace this s here with 0, here I'll then have 0. 2 times 0 will give us 0, then 0 plus 1 will give us 1, and the square root of 1 is 1, then 1 plus 1 is 1. That means that if s is 0, this whole side will give us 2, and here will then be 0. So this is absurd. This is absurd. So our s equals to 0 cannot be a solution because it did not satisfy the original equation. And if s is equals to 4, that means I'm going to replace s here with 4. Then I'm going to have 2 times 4, which is 8. Then 8 plus 1, which is 9. Then square root of 9 is 3. Then 3 plus 1 is 4. And so we are going to get that 4 is equals to 4. Therefore, the only solution of s that will satisfy this equation is s equals to 4. This is how you solve Surdic equation. See you in the next lesson.